Hi everyone. In our last two lessons, we have done GCF, or greatest common factor of numbers only, and then we did the same thing, GCF of terms, when you include variables. And really the reason we did both of those lessons is because we are going to use GCF today to do what's called factoring out common terms. Now, to show you exactly what we're doing, I'm going to start with an example that we've already done this year. This is an example of what we call the distributive property. We have 3x squared, that's a single term, times, and then in parentheses we have a polynomial. In this case it's 2x minus 4. So if I were doing this question, what I would do is I would take the 3x squared and do two separate multiplication problems. Remember, we use these arrows to show that we're multiplying. So for the first step, I would do 3x squared times 2x. And for the second step, I would do 3x squared times negative 4. So for our final answer here, for the first term right here, I would do number part first, 3 times 2 is 6. And then variable part second, x squared times 1 more x would give you x cubed. Remember, just add the exponents. Then for my second term right here, number part, 3 times negative 4 is negative 12. And we'll just leave the x squared. We don't have any more x's to combine it to. All right, that was a review of distributive property. Now, the reason I wanted to review that with you guys, when you're factoring out common terms, what you're actually doing is working that question backwards. You're starting with 6x cubed minus 12x, and you're ending with 3x squared times parentheses 2x minus 4. So let's talk about how we can do that. We want to be able to work questions like that one backwards. We want to start with the polynomial and end with the distributive property question. So the question we're asking ourselves, if we want to focus on the last example we just did, if I started with 6x cubed minus 12x squared, how could we turn it into 3x squared times, and then parentheses, 2x minus 4? Now the idea is we're going to use inverses. On distributive property, we multiplied to put the number into parentheses. We're going to do the opposite. The opposite of multiplying is dividing. So we are going to divide to take that number out of the polynomial, or out of the parentheses. Now, the reason we just finished studying greatest common factor, that's how you're going to pick this number right here. That's how you're going to know what to divide by. You're going to look at the terms in this polynomial. You're going to figure out the GCF, just like we spent 2 days doing, and that's what you're going to divide out. So this process is called factoring out common terms. The common term is basically the GCF, the greatest common factor, and we are going to factor it out or divide it out and bring it out of the polynomial. And what we just noticed in that example is basically the distributive property backwards applied to a polynomial. So here are the steps. Step 1, if you want to factor out common terms, you need to decide what to factor out. So you look at the polynomial and you find the GCF, or the greatest common factor. If you need a review on how to do that, remember we already did a video on that. Just go back and watch the last video we did. Then you take your polynomial, you divide. Remember, when we're doing distributive property, we multiply to put a number into the parentheses. Now we are going to divide to take it out. So we're going to divide every term of the polynomial by that GCF. Then when you divide it, remember we're doing distributive property backwards. It comes out front. So you're going to take that GCF and you're going to write it in front of the parentheses. And inside the parentheses, after you do the dividing, you're basically done. That's what's left over inside the parentheses. So let's take a look at an example. Let's factor out all common terms of 12x squared plus 9. And what I would probably do here, let's go off to the side and let's find the GCF, the greatest common factor. So let's do the number part first. We're asking ourselves, what's the biggest number that we can divide both 12 and 9 by? If you need to do factor trees like we did the first time, you can, or you can start running through them in your head. I'll do the factor trees just for this one example. 12 could be 1 times 12, it could be 2 times 6, or it could be 3 times 4, and that's it. 9 could be 1 times 9, or 3 times 3. Now the biggest number that we find on either list or on both lists is 3. So far, the greatest common factor is 3. Then we check the x's because this has terms in it. So the 12x has an x in it, the 9 does not. If one of the terms doesn't have one of the variables, then that variable is not part of the GCF. So my greatest common factor is 3. That's what we just figured out. Now, here's the work. Once you figure out what the greatest common factor is, I'm going to go ahead and put parentheses around this. I'm going to take everything in this polynomial and I'm going to divide by the greatest common factor. So I'm going to divide it by 3. Now remember, we're doing distributive property backwards. So what's happening now, when you divide instead of multiply, that 3 comes out front. Now, to figure out what's left over in the parentheses, just finish the dividing part. So for the 12x divided by 3, I say 12 divided by 3 is 4, and then just leave the x on your answer. Plus, and then 9 divided by 3 is 3. And that's your answer. That's distributive property backwards. Instead of taking 3 times 4x plus 3 and multiplying and getting 12x plus 9, we're starting with the 12x plus 9. We're dividing the 3 out and seeing what's left over. But remember, you have that problem at the beginning. You have to decide what to divide by. You have to find the GCF, or the greatest common factor, to decide what to factor out. Here's another example. Let me do the GCF off to the side again. We have 3 terms this time. I have a 4, I have a 2, and I have a 5. There's no number that divides into, I mean, you could say a 1 if you want, but really there's no number that divides evenly into 2, 4, and 5. Again, I'll show you the work one more time. 4 could be 1 times 4 or 2 times 2. 2 is 1 times 2 and that's it. And 5 is 1 times 5 and that's it. So yeah, the biggest number you have on any of these lists, or on all 3 of the lists, is 1. So you can put a 1 here if you want, but you don't really need it. All right, now I look at the variable. The variable is m. I have an m to the 5th, an m squared, and an m by itself, which remember means m to the 1st power. And our little shortcut tells us the lowest power of m is the common term. So m to the 1st power is our greatest common factor. Now the way I wrote it was 1m to the 1st power, but I would probably just leave those ones off and say the greatest common factor is m, because that's what 1m to the 1st power is. Now we're going to finish the question just like the last one. Once you realize what that common factor is, you are going to divide everything by that common factor. In this case, it's an m. And remember, by doing that, we are taking that m out of the parentheses and bringing it out front. So the m comes out front, and let's see what's left over. Now, if you remember when we did our properties of exponents a little while ago, we said when you're dividing, you're subtracting the exponents. So these are all m to the 1st powers right here. So basically, when I divide 4m to the 5th by m to the 1st, I'll leave the 4. And then I subtract the exponents on the m. 5 minus 1 is 4, so I get 4m to the 4th power. For the middle term, I will leave the 2. And then I have m to the 2 minus 1 is 1. So you can put the 1 or you can leave it as 2m. Minus, now here on the last term, it's actually kind of nice. The m's cancel out. So you just get a minus 5 there. And that's your final answer. We factored out an m. That m comes out front. And then what comes after it is 4m squared plus 2m minus 5. Let's do one more. Last example for today. We have 10x to the fifth minus 5x squared. Let's do the GCF off to the side again. The biggest number that divides into both 10 and 5 is 5. I'm not even going to do the factor tree for this one because I can kind of see it. The biggest number that you can divide both 10 and 5 by is 5. Now for the x's, I have an x to the fifth and an x squared. So remember our little shortcut, always the lower exponent. That would be x squared. So the greatest common factor of 10x to the fifth and 5x squared is 5x squared. Now, just like last time, once you realize the greatest common factor, we are going to divide by that, and that brings it out front. So that 5x squared comes out front, and once you do the dividing part, you'll see what's left over in the parentheses. So for my first term, 10 divided by 5 would be 2. And x to the fifth divided by x squared, you subtract the exponents. 5 minus 2 is 3. So I get 2x to the third power. Now the minus sign we'll just leave. I did this in the last one too. I think it was a plus. We left it. Now what happens here, 5x squared divided by 5x squared is actually 1. Whenever you divide anything by itself, you get a 1. See, what happens is kind of everything cancels out. The 5 cancels with the 5. The x squared cancels with the x squared. And just remember, if you ever cancel everything, it doesn't leave a 0, it leaves a 1. Because that's how fractions work. If I asked you what is 10 over 10, it means 10 divided by 10, the answer is 1. So any number over itself in a fraction always equals 1. But this is our final answer. And now you guys can see how factoring out common terms works. It has to do with step 1, finding the greatest common factor, realizing what you need to divide by, but then step 2, you actually divide it out. You do a distributive property backwards. You divide each term by that greatest common factor, and then it comes out of the parentheses back to the front of the problem.